Welcome back to Algebra 1 Honors. This is lesson 8-6, all about functions. Now, functions are something that you will see again and again in math, and you will see a lot of them in calculus when you get to calculus. And they're not a very hard idea. Here's an example of what a function is. Okay? A function is a mapping, right, where we have a set of inputs and we map them to a set of outputs. The inputs are called the domain, and the outputs are called the range. Okay? And let me give you an example to make it very, very clear. If over here I have a set of names, me, my brother, my father, and maybe your name, okay? And my function is to map the name to that name's birth or that person's birthday. Well, mine would map over here in the range to 6/15/55. That's my birthday, June 15th, 1955. Now, my brothers would map to August 12th, 1958. Okay? And my father's would map to August 9th, 1930. Okay? And yours would map to whatever your birthday is, your birth date. Okay? Now, this is a function because each input over here, each element of the domain maps to only one element in the range. Okay? In other words, for me, I don't have two different birth dates. I was only born once. Okay? And my brother has only one birthday. So does my father, and so do you. Okay? Now, if you come down here, though, and if we turn this around and we say we have birth dates or birthdays over here, like the 15th of June, 1955, and over here we list all the people who were born on that day, well, there's going to be me, there's going to be my best friend Cheryl, and then there's going to be all the other people in the world that were born on June 15th, 1955. And there are probably thousands of them, if not millions of them. Same thing here. If I put in my father's birth date, 8/9/30, then it's going to map to my father's name, but also to all of the other people who were born on that same day that he was born. Again, thousands at least. Okay? So this is a function up here. This is not a function down here. Because up here, each element, each different item in the domain has only one matched item in the range. Okay? And down here, elements in the domain map to many elements in the range. Okay? Now, let me clarify one more thing, because this is one that gets people a lot of times. If you have a domain over here, like this, and let's say it's a bunch of numbers, 1, 2, 3, and so on. And over here you have a range. Okay? So it only has two values in it. It's okay, it's still a function if 1 maps to 0, 2 maps to 0, and 3 maps to 0. Okay? There's nothing that says that different elements in the domain can't all match up with the same element. Like maybe it was my name, my brother's name, and your name, and we all love chocolate cake, right? That would be our favorite dessert. And maybe down here is lemon pie. Well, it's okay for 3 of us who are different over here all to map to chocolate cake as our favorite dessert. Okay? So different elements in the domain can all map to the same one. It's just that if I had, like me here in the domain, and I said my favorite desserts are chocolate cake and lemon pie, that would not be a function. So in the domain, each element in the domain can only have one arrow leading from it, mapping to an element in the range. Okay? Now, there are a lot of different ways, besides drawing a picture like that, a graph like that, to represent this information. One way you might see is ordered pairs, where they have something like this. ordered pair symbol there. There's my brother, my father, okay, and you, okay? And the way that you're going to tell if this is a function or not, is to say, okay, is there another Miss Moran in the x values here? So you look at all the x values, brother, father, you. No, there's only one. So it maps to only one item. Okay? There are a lot of different ways to draw a function or show a function. Now, let's look at an actual graph and see how you tell on a graph whether something is a function or not. All right, let's say we have x equals 2y. Here's our Cartesian coordinate system here. Okay, and we're going to, this is a line because we have an x and a y with exponents of 1. So we need 2 points. If I pick 0 for x, then y has to be 0. If I pick 1 for y, then x has to be 2. And there's my 2 points. So I'm going to plot 0, 0 right here. And 2, 1. Over 2, up 1 right there. And there's my line. Okay? Now, the question is that a function or not? Okay? And you answer that by doing something very simple. It's called the vertical line test. It means you imagine taking a super skinny pencil, much, much skinnier than this marker, okay, infinitely skinny. You hold it vertical like this, and you pass it over this way. And anywhere along the way, if you hit your graph, what you've drawn, in 2 places at the same time, then you do not have a function. So this line, this red line that I drew here, no matter where I go, I'm only crossing that line at 1 point. Okay, 1 point. If I have a circle, let's say that I had a circle up here. Okay, that nice circle. Then if I take my marker and I go across, well, right there, I'm hitting at 2 points, right here and right here. On the line right there, I'm hitting at 2 points, right here. Okay, so you can see there are a lot of places where my vertical line hits my picture, hits my graph, in 2 places at the same time. And the reason that flunks the function test is because my x value here is 0, 3. And my x value here, or my point, is 0, 6. So I have the same x, the same domain, with 2 different y values. It'd be like in my original picture, like I had 0 here, and it mapped to 3, and it mapped to 6. Okay? So, for a picture, for a graph, you do the vertical line test. You take your pen or pencil, pass it along your picture, and anywhere, if you hit 2 points of your picture, of your graph, at the same time with your vertical line, it's not a function. Because that means you have the same x value with 2 different y values. Okay? And that is what functions are.